Hello there, and welcome to Calm Science. I am glad you are here. Take a moment now to find a position that feels comfortable and soft. Let your body settle into the surface that supports it. Allow your breath to find its own easy rhythm without any effort needed. There is nothing to do right now, nothing to solve. The day can begin to fade. Tonight we journey to a world that is quiet, cold, and still. We are drifting toward our planetary neighbor Mars, a world of faint red dust, towering silent volcanoes, and canyons that stretch in profound stillness. We will wander across its ancient landscapes, learning about its thin air and its two small moons, its past waters and its deep, quiet history. You can allow your mind to drift in and out of the story. The thread will remain simple and calm. There is no need to hold on to any single thought. Simply rest and let the gentle current of discovery carry you toward sleep. Fact 1. As you rest, we can begin our journey with a simple picture of Mars. It is the fourth planet from the Sun, orbiting in the cold stillness of space. Its familiar reddish color comes from a fine layer of iron oxide dust that covers its surface, much like rust. This color gives it the name the Red Planet. This dust is incredibly fine, like powdered sugar, and it blankets everything in a soft ochre hue. From a distance, this color is its most defining feature, a warm tone in the cold darkness. It is not a fierce red, but a gentle, earthy color, the shade of ancient rock that has weathered over billions of years. It speaks of a world that is old and has been patiently waiting in the quiet of the solar system. Let the body be held by what supports you. Fact 2. The rhythm of a day on Mars is surprisingly familiar. A Martian day, which scientists call a sol, lasts just a little longer than a day on Earth. It is 24 hours, 39 minutes, and about 35 seconds long. This means that if you were standing on the surface of Mars, the sun would rise and set in a cycle very similar to the one we know. The gentle transition from daylight to evening occurs at a pace our bodies would recognize. This similarity in the length of a day is a quiet coincidence, a familiar pulse in a world that is otherwise very different from our own. It is a steady, predictable rhythm that is repeated for eons, undisturbed. Rest in the quiet that follows. Fact 3. While a Martian day is familiar, a Martian year is much longer. Mars takes longer to travel around the Sun, following a wider, slower path. 1 year on Mars is about 687 Earth days long. This is almost twice the length of a year on Earth. This means that the seasons on Mars stretch out for nearly double the time. The long, slow winters and the equally long, mild summers unfold at an unhurried pace. Everything on this silent planet happens on a grander timescale. The journey of Mars through space is a patient one, a slow loop that it has traced countless times. The passage of time feels different there, measured in slower, deeper cycles. Let the thoughts soften at the edges and fade. Fact 4. The atmosphere of Mars is very different from our own. It is incredibly thin, about 100 times less dense than Earth's atmosphere at sea level. This thin veil of gas is made up mostly of carbon dioxide, with very small amounts of other gases like nitrogen and argon. Because the air is so thin, it does not hold heat well. The sky is not a deep blue, but a pale butterscotch color. The air also offers little protection from the sun's radiation. This thin blanket of air means that sounds would be muffled and faint, and the wind, even when strong, would not push with much force. It is a world of profound quiet, where the air itself is just a whisper. Feel the calm gather around you again. Fact 5. Unlike Earth, Mars does not have a global magnetic field. Earth's magnetic field acts like a protective shield, deflecting harmful solar wind and cosmic rays. Mars once had a strong magnetic field, but it faded away billions of years ago. Today, only small, remnant pockets of magnetism exist in its crust, like fossilized memories of its past. Without a global shield, the solar wind has slowly stripped away much of the planet's early atmosphere over billions of years. This is a primary reason why the air there is so thin today. This process happened with unhurried steps, a gradual erosion over an immense span of time, leaving the planet exposed and beautifully still. Return to the easy rhythm of your breath. Fact 6. From a distance, the most striking features of Mars are its polar ice caps. Just like Earth, Mars has large white caps at its north and south poles. These are not made entirely of water ice. The polar caps are composed of 2 layers. The base layer is made of water ice, and it is very thick, remaining frozen year-round. On top of this water ice is a thinner, seasonal layer of frozen carbon dioxide, which you might know as dry ice. This top layer appears in the winter when temperatures drop low enough for the carbon dioxide in the atmosphere to freeze and fall like snow. This creates a beautiful, shifting landscape of white against red. Let your shoulders drop and the jaw unclench. Fact 7. The polar caps of Mars change with the seasons, growing and shrinking in a slow, steady rhythm. During the Martian winter, one pole is tilted away from the sun, and darkness and cold descend. Temperatures plummet low enough for carbon dioxide from the atmosphere to freeze onto the surface, expanding the size of the ice cap. Then, as spring arrives, the pole tilts back toward the sun. The sunlight warms the surface, and the frozen carbon dioxide turns directly back into a gas, a process called sublimation. The cap shrinks back, revealing the permanent water ice layer underneath. This quiet planetary breathing has continued for ages, a cycle of freezing and warming that redraws the planet's poles each year. Set the idea down and feel the weight release. Fact 8. Rising gently from the Martian plains is the largest volcano in our solar system, Olympus Mons. This is not a steep conical mountain, but a vast shield volcano with very gentle slopes. If you were standing at its base, you would not be able to see the summit because the volcano is so wide and its incline is so gradual. It grew layer by patient layer over millions of years as fluid lava flowed out and solidified. Because Mars has lower gravity and a lack of tectonic plate movement, the volcano was able to grow uninterrupted in one spot for an incredibly long time. Up close, its slope is more like a gentle hill that simply keeps going, rising softly into the thin Martian sky. Rest in the steady comfort of this moment. Fact 9. The scale of Olympus Mons is difficult to imagine. The base of the volcano is about 600 kilometers across. That is roughly the size of the state of Arizona. It rises to a height of about 22 kilometers, which is nearly 3 times the height of Mount Everest above sea level. At its summit is a large caldera, a collapsed crater complex that stretches for over 80 kilometers. This single mountain is so vast that it stands above the thin Martian atmosphere, with its peak poking into the near vacuum of space. It is a quiet giant, a testament to a time when the planet's interior was much more active, slowly and persistently building this monumental structure. Let that settle like dust on a quiet floor. Fact 10. Elsewhere in this picture, Olympus Mons is not alone. It sits on the edge of a massive volcanic highland called the Tharsis region. This area contains several other enormous shield volcanoes. The most notable are a group of 3 large volcanoes known as the Tharsis Montes. Their names are Arsha Mons, Pavonis Mons, and Ascraeus Mons. They form a nearly straight line, and like Olympus Mons, they are unimaginably large by earthly standards. This entire region is a huge bulge on the Martian surface, lifted up by volcanic activity from deep within the planet's past. These silent mountains stand as monuments to a more geologically dynamic era, their vast forms now sleeping under a thin layer of red dust. Let the body grow heavier as the mind stays simple. Fact 11. Stretching across the equator of Mars is another feature of immense scale, a vast system of canyons called Valles Marineris. It is often called the Grand Canyon of Mars, but this comparison does not do it justice. Valles Marineris is much, much longer, deeper, and wider. It is not a single canyon, but a network of interconnected chasms, troughs, and valleys that stretches for a significant portion of the planet's circumference. This feature was not carved by water like Earth's Grand Canyon. Instead, it is a massive tectonic crack, a scar that formed as the crust of the planet stretched and pulled apart, likely due to the volcanic activity in the nearby Tharsis region. Hold the shape of that thought lightly and return to ease. Fact 12. To understand the size of Valles Marineris, we can look at its dimensions. The canyon system stretches for over 4,000 kilometers. This is long enough to span the entire continental United States from east to west. In places, the canyons are up to 7 kilometers deep. This is more than 4 times deeper than the Grand Canyon on Earth. The canyons are also incredibly wide, some reaching over 200 kilometers from rim to rim. If you were standing on one edge, you would not be able to see the other side. You would simply be looking out over a vast, hazy chasm that disappears into the distance. It is a place of profound emptiness and staggering scale. You can breathe a little deeper and allow the thought to drift. Fact 13. The formation of Valles Marineris is a story written in stillness. Most scientists believe it began to form billions of years ago as the Tharsis bulge grew. The immense weight of the Tharsis volcanoes stressed the Martian crust, causing it to stretch and break. These initial cracks were then widened and deepened over eons by other processes. Landslides, wind erosion, and perhaps even the removal of subsurface water or magma, all played a part in shaping the canyons we see today. The process was not violent or sudden, but a slow, gradual tearing apart that unfolded over countless millennia. The canyons are a silent record of the planet's immense geological stress, now resting in quiet repose. Nothing urgent here, only a slow and steady pattern. Fact 14. In the southern hemisphere of Mars lies another remarkable feature, a giant impact basin named Hellas Planitia. This is one of the largest and oldest impact craters in the entire solar system. It is a vast, roughly circular depression that stretches for about 2,300 kilometers in diameter. Its floor is more than 7 kilometers below the surrounding plains, making it one of the lowest points on the planet. The impact that created this basin must have been cataclysmic, an event that occurred very early in the solar system's history. Today, the basin is a calm and empty place. The air at the bottom is slightly denser than elsewhere on Mars, leading to slightly different weather patterns within its vast, quiet expanse. Let that idea rest for a moment before we move on. Fact 15. From a distance, one of the most mysterious features of Mars is the sharp contrast between its northern and southern hemispheres. This is known as the Martian dichotomy. The southern hemisphere is high, rugged, and densely covered with impact craters, indicating that it is a very old surface. In contrast, the northern hemisphere is low, smooth, and has very few craters. It is as if the planet is cleanly divided into two different worlds. This vast, smooth area in the north is known as the northern lowlands. This drastic difference has puzzled scientists for decades, suggesting a planet with two distinct histories, one for the north and one for the south. The red planet keeps its steady, silent pace. Fact 16. One of the leading explanations for the smoothness of the northern lowlands is the idea that they were once the site of a vast ocean. Billions of years ago, when Mars had a thicker atmosphere and a warmer climate, liquid water may have pooled in this enormous basin. The smooth, flat plains we see today could be the ancient seafloor, covered now by layers of sediment and dust. Orbiters have detected features along the edge of these lowlands that resemble ancient coastlines. The idea of a lost Martian ocean is a beautiful one, suggesting a world that was once much more like Earth, with blue water under a warmer sky. These quiet plains may hold the memory of ancient tides. Let your breathing find a slower pace. Fact 17. Across the surface of Mars, especially in the older southern highlands, we find compelling evidence of past water. Orbiters have photographed intricate networks of dried-up river valleys, channels, and deltas. These features look remarkably similar to water-carved landscapes on Earth. Some of these valley networks are extensive, suggesting they were carved by flowing water over long periods. In other places, we see the fan-shaped deposits of ancient river deltas, where rivers once emptied into crater lakes or larger bodies of water. These ancient watercourses are now completely dry and silent, etched into the landscape like faint memories of a wetter, more dynamic past. Hold only the calm and let the rest drift. Fact 18. Up close, the rovers that have explored Mars have found even more direct evidence of past water. The Opportunity rover discovered small spherical concretions of the mineral hematite, which a scientist nicknamed blueberries. On Earth, these nodules typically form in the presence of water. Elsewhere, the Curiosity rover found minerals like gypsum and clay, which also form in wet environments. It even drilled into sedimentary rocks that were clearly formed from mud at the bottom of an ancient lake. These minerals are the chemical fingerprints left behind by water, quiet confirmation that liquid water once flowed and pooled on the Martian surface, perhaps for millions of years. Feel the simple ease of being here. Fact 19. While liquid water is no longer stable on the surface today, a vast amount of water is still present on Mars, frozen as ice. We have already mentioned the large water ice caps at the poles. But beyond the poles, orbiters have detected huge amounts of subsurface water ice hidden just beneath the planet's dusty surface. In some mid-latitude regions, there are entire glaciers of water ice covered by a thin layer of rock and dust. This buried ice is a significant reservoir of water. It is a remnant of a colder, icier period in the planet's history, preserved in the frozen ground. In quieter hours, the planet holds its history just below the surface. Allow the day to fall away now. Fact 20. The weather on Mars is driven by the vast temperature differences between the equator and the poles, and between day and night. The thin air cannot hold much heat, so temperatures can swing dramatically. While the weather is often calm, Mars is famous for its dust storms. Local dust storms are quite common. kicking up the fine red dust into the atmosphere. These can grow and merge, and occasionally they can escalate into enormous planet-encircling events. These global dust storms are a unique feature of Mars, a phenomenon that happens nowhere else in the solar system. The planet becomes shrouded in a dusty haze for weeks at a time, settle back into the soft pace of night. Fact 21. When a global dust storm occurs on Mars, it is a slow and gradual event. The process begins with smaller storms that merge and grow, feeding off each other's energy. Over weeks, a hazy veil of dust lifts high into the atmosphere, eventually shrouding the entire planet. From space, all surface features disappear beneath a uniform, dusty pall. The amount of sunlight reaching the surface drops significantly, and temperatures become more uniform across the planet. These storms can last for months before the dust slowly begins to settle again. It is a quiet, powerful process that transforms the entire planet. A slow dance of wind and dust on a global scale. There is only stillness in this ancient landscape. Fact 22. If you could stand on Mars, the world would sound very different. The thin carbon dioxide atmosphere would make sounds quiet and muffled. Sound travels more slowly through the thin air, and higher-pitched sounds would be absorbed much more quickly than lower-pitched ones. This means that the soundscape would be dominated by low rumbles. The wind might howl, but it would sound distant and faint, more like a whisper than a roar. The landing of the Perseverance rover allowed us to hear the sounds of Mars for the first time, confirming this quiet reality. It is a world of incredible visual grandeur but audio subtlety, a place where even the wind is gentle on the ears. Feel the calm gather around you again. Fact 23. While the Martian sky is a pale butterscotch color during the day, its sunsets are a beautiful, surprising blue. This is the opposite of what we experience on Earth. On our planet, the sky is blue and sunsets are red. On Mars, the sky is reddish-pink and the sunsets are blue. This happens because of the fine red dust in the atmosphere. This dust scatters red light forward toward an observer looking at the setting sun. So, the area of the sky immediately around the setting sun appears blue, while the rest of the sky remains a faint pink. These blue sunsets are a gentle and otherworldly spectacle, a calm and beautiful closing to the Martian soul. Let your shoulders drop and the jaw unclench. Fact 24. Mars is accompanied on its journey through space by two very small moons named Phobos and Deimos. Their names mean fear and dread, named after the sons of the Greek god of war, Ares, who is the equivalent of the Roman god Mars. These moons are not spherical like Earth's moon. Instead, they are small, lumpy, and irregularly shaped, looking more like asteroids or potatoes. They are among the smallest moons in the solar system. Deimos is only about 12 kilometers across, while Phobos is slightly larger at about 22 kilometers. They orbit very close to Mars and are difficult to see from Earth without a powerful telescope. Return to the easy rhythm of your breath. Fact 25. The origin of Phobos and Deimos is a quiet mystery. Their small size, irregular shape, and dark cratered surfaces are very similar to certain types of asteroids found in the outer asteroid belt. Because of this, the leading theory is that they are not original moons that formed with Mars. Instead, they are likely captured asteroids, wanderers that strayed too close to Mars long ago and were pulled into orbit by its gravity. They are bits of cosmic history from another part of the solar system, now bound to the red planet in a slow, eternal dance. Through a soft lens, they are ancient travelers resting in a new home. Set the idea down and feel the weight release. Fact 26. The orbit of Phobos is unusual and ultimately it is doomed. It orbits incredibly close to Mars, closer than any other moon to its planet in the solar system. It is so close that it whips around Mars in just under 8 hours, faster than Mars rotates. This means that from the Martian surface, Phobos would appear to rise in the west and set in the east several times a day. Because it is so close, the tidal forces from Mars are slowly pulling Phobos inward. In about 50 million years, it will either crash into the planet or be torn apart by gravity, forming a faint, dusty ring around Mars. Its fate is a slow, inevitable decay. Rest in the steady comfort of this moment. Fact 27. The other moon, Deimos, has a very different future. It orbits much farther away from Mars than Phobos does. Its orbit takes about 30 hours, which is a bit longer than a Martian day. Unlike Phobos, which is being pulled closer, Deimos is in an orbit that is slowly causing it to drift farther and farther away from Mars. The process is incredibly gradual, happening on a time scale of millions of years. Eventually, far in the future, it may escape Mars's gravity altogether and wander back into the solar system as a lone asteroid once again. In this way, the two moons follow opposite paths, one spiraling inward toward its end, the other drifting gently away into the darkness. Let that settle like dust on a quiet floor. Fact 28. Our understanding of Mars has been transformed by the robotic explorers we have sent there. Before rovers, our first close-up views came from landers. The Viking 1 and Viking 2 missions in the 1970s were the first to successfully land on the surface and operate for an extended time. They sent back the first pictures from the ground, showing a rocky, desolate, and beautiful landscape. They also conducted experiments to search for signs of life in the soil. While those tests were inconclusive, the Viking missions laid the groundwork for all future exploration of the Red Planet. They were the first to touch the surface and experience the quiet stillness of that world. Let the body grow heavier as the mind stays simple. Fact 29. The first wheeled vehicle to explore another planet was the Sojourner rover, which landed on Mars in 1997 as part of the Mars Pathfinder mission. Sojourner was very small, only about the size of a microwave oven. It was designed to be a technology demonstration, to prove that roving on Mars was possible. The mission was a tremendous success, capturing the world's imagination. The little rover cautiously explored the area around its landing site, which was named the Carl Sagan Memorial Station. It analyzed the composition of rocks and soil, giving us our first ground-level chemical analysis of the Martian surface. It was a small first step for a much larger journey of discovery. Hold the shape of that thought lightly and return to ease. Fact 30. In 2004, a pair of twin rovers named Spirit and Opportunity landed on opposite sides of Mars. They were much larger and more capable than Sojourner. They were designed as robotic geologists, sent to search for evidence of past water activity. Both rovers were designed to last for about 90 Martian sols, or about 3 months. But they proved to be incredibly resilient. Spirit explored a region called Gusev Crater and found evidence of a past environment that was steamy and volcanic. It operated for more than 6 years before finally getting stuck in soft soil. Meanwhile, on the other side of the planet, its twin was just getting started. You can breathe a little deeper and allow the thought to drift. Fact 31. The Opportunity rover landed in a small crater in a flat plain called Meridiani Planum. Almost immediately, it found exactly what it was looking for: clear geological evidence that liquid water had once existed there. Its 90-sol mission turned into an incredible journey that lasted for nearly 15 years. The rover traveled over 45 kilometers, the longest distance ever driven on another world. It journeyed from crater to crater, patiently analyzing rock layers that told a story of an ancient, watery past. The long life of Opportunity was a testament to its robust design and the dedicated team that operated it. Its mission finally ended in 2018 when a global dust storm cut off its solar power. Nothing urgent here, only a slow and steady pattern. EFAC 32. The next generation of rover was Curiosity, which landed in 2012. It is the size of a small car, much larger and more powerful than Spirit and Opportunity. It is also nuclear-powered, so it is not dependent on sunlight. Curiosity landed inside a large impact crater called Gale Crater. The crater was chosen because it has a huge mountain in its center named Mount Sharp. The layers of this mountain are like the pages of a history book, with the oldest layers at the bottom and the youngest at the top. The rover's mission is to slowly climb this mountain, reading the geological history of Mars as it goes. Allow the mind to idle in gentle space. Fact 33. As Curiosity has slowly made its way up the slopes of Mount Sharp, it has made remarkable discoveries. The rover found that Gale Crater was once home to a long-lasting lake of fresh water billions of years ago. The conditions in this lake would have been habitable, meaning it had all the necessary ingredients to support simple microbial life. It found sedimentary rocks, like mudstone, that formed from fine silt settling at the bottom of this ancient lake. It has analyzed the chemical composition of these rocks, finding carbon, hydrogen, oxygen, and other key elements for life. As you rest, the rover continues its quiet climb, piecing together the story of a lost, watery world. Let that idea rest for a moment before we move on. Fact 34. The most recent rover to land on Mars is named Perseverance. It touched down in 2021 in a place called Jezero Crater. This landing site was chosen because orbiters had identified a clear, fan-shaped river delta there. This is a place where a river once flowed into a crater lake, depositing sediment. Perseverance has a primary mission that is different from previous rovers. Its main goal is to search for signs of ancient microbial life, or biosignatures. It is equipped with advanced instruments to look for telltale chemical or textural signs that life may have once existed in this ancient lake environment. It is the first mission since Viking to directly search for evidence of life. The red planet keeps its steady, silent pace. Fact 35. Accompanying the Perseverance rover was a small, experimental helicopter named Ingenuity. Its mission was to attempt the first powered, controlled flight on another planet. Flying on Mars is incredibly difficult because the atmosphere is so thin. An aircraft's blades have to spin much, much faster to get enough lift. Ingenuity was designed for just a few test flights, but like the rovers before it, it far exceeded its expected lifetime. It successfully flew dozens of times, acting as a scout for the Perseverance rover, mapping out terrain and identifying interesting features ahead. It proved that aerial exploration of Mars is possible, opening up a new way to see the red planet. Let your breathing find a slower pace. Fact 36. We have mentioned the blue sunsets on Mars. During the day, the sky has a different but equally unique color. Because of the fine red dust suspended in the thin atmosphere, the daytime sky on Mars is not blue like Earth's. Instead, it appears as a pale, pinkish yellow or butterscotch color. The ever-present dust particles scatter red light across the sky, giving it this warm, gentle tone. Looking up from the Martian surface, you would see the soft, tawny sky stretching over the red, rocky landscape. It is a muted and serene canvas, very different from the bright, vibrant sky of our own world. There is only stillness in this ancient landscape. Fact 37, the temperatures on Mars are extremely cold. Because of its thin atmosphere and its greater distance from the sun, Mars is not able to hold on to heat. The average temperature across the entire planet is about -63 degrees Celsius. Even on a summer day at the equator, temperatures might reach a comfortable 20 degrees Celsius. But at night, the temperature would plummet to -73 degrees Celsius or lower. At the poles in winter, it can get as cold as -125 degrees Celsius. This constant deep cold is one of the defining features of the modern Martian environment, a world locked in a permanent state of deep freeze. Hold only the calm and let the rest drift. Fact 38. Another consequence of the thin Martian atmosphere is its very low pressure. The atmospheric pressure on the surface of Mars is less than 1% of Earth's at sea level. This low pressure has a strange effect on water. If you were to place a cup of liquid water on the surface, it would not stay liquid for long. It would begin to boil, even at very cold temperatures, because there is not enough air pressure to hold it in a liquid state. The water would rapidly turn to vapor and disappear into the thin air. This is why liquid water is not stable on most of the planet's surface today. It can only exist as ice or as a short-lived, briny flow in certain conditions. Feel the simple ease of being here. Fact 39. Across the flat plains of Mars, a common weather phenomenon is the dust devil. These are much like the dust devils that form in deserts on Earth. But they can be much larger on Mars. They are swirling columns of air and dust that form on sunny days when the ground heats up faster than the air above it. The warm air rises, and under the right conditions it can begin to rotate, picking up loose dust from the surface. Martian dust devils can be dozens of times larger than their earthly counterparts, sometimes reaching several kilometers high. They travel silently across the landscape, cleaning the dust off of rocks and even the solar panels of rovers as they pass. Allow the day to fall away now. Fact 40. In recent years, orbiters have observed mysterious dark streaks that appear on some crater walls and steep slopes during the warmest Martian months. These features are called recurring slope lineae. They appear in the spring, grow longer down the slopes in the summer, and then fade away in the autumn and winter, only to reappear the next year. One theory is that these streaks are caused by the seasonal flow of very salty water or brine. The high salt content would allow the water to remain liquid at lower temperatures. While not definitive, these features suggest that small amounts of liquid water might still be seeping to the surface today. Settle back into the soft pace of night. Fact 41. The idea of making Mars more Earth-like is a popular concept known as terraforming. In this process, we would theoretically try to thicken the atmosphere, warm the planet, and restore liquid water to its surface. The process would be incredibly long and difficult. It would likely start by releasing vast amounts of greenhouse gases, such as carbon dioxide, which are currently locked in the polar ice caps in the soil. This would slowly warm the planet and increase the atmospheric pressure. Over centuries or millennia, this might allow for liquid water and perhaps even simple plant life. For now, it remains a distant dream, a gentle thought about a possible future. Feel the calm gather around you again. Fact 42. Mars has seasons just like Earth does. This is because the rotational axis of Mars is tilted at an angle of about 25 degrees, which is very similar to Earth's tilt of about 23.5 degrees. It is this axial tilt that causes one hemisphere to receive more direct sunlight, while the other receives less, leading to summer and winter. However, because a Martian year is nearly twice as long as an Earth year, each season on Mars lasts for about 6 months. This gives the planet a long, slow rhythm of changing weather, shifting ice caps, and migrating dust that unfolds over a much grander timescale. Let your shoulders drop and the jaw unclench. Fact 43. The orbit of Mars around the Sun is more stretched out, or elliptical, than Earth's nearly circular path. This means that at some points in its year, Mars is significantly closer to the Sun than at other times. This variation in distance has a strong effect on its seasons. When Mars is closest to the Sun, an event called perihelion, the planet receives about 40% more solar energy than when it is farthest away, at aphelion. This makes the seasons in the southern hemisphere more extreme than in the northern hemisphere. The southern summers are short and hot, while the northern summers are long and cool. Return to the easy rhythm of your breath. Fact 44. The elliptical orbit of Mars also influences its dust storm activity. The planet-encircling dust storms tend to occur during the southern hemisphere's spring and summer. This is the time when Mars is closest to the Sun in its orbit. The increased solar heating energizes the atmosphere, making it more dynamic and more likely to kick up large amounts of dust. This orbital timing creates a predictable storm season on Mars. It is a pattern driven by the planet's celestial mechanics, a slow dance of distance and sunlight that stirs the quiet dust and sends it swirling across the globe. Through a soft lens, this cycle is part of the planet's ancient character. Set the idea down and feel the weight release. Fact 45. Deep beneath the surface, the core of Mars is thought to be made primarily of iron and nickel, with a significant amount of a lighter element, likely sulfur. Scientists believe the core is at least partially liquid. However, it seems that the molten iron in the core is no longer convecting in a way that generates a global magnetic field. The planet's internal dynamo has shut down. The size of the core is still being studied. Recent data from the InSight landers suggests it is larger and less dense than previously thought, which helps explain why the planet cooled down faster than Earth and lost its magnetic shield so early in its history. Rest in the steady comfort of this moment. Fact 46. Surrounding the core of Mars is a thick, rocky mantle. This mantle is composed of silicate rocks, similar in composition to Earth's mantle. In the planet's distant past, this mantle was hot and actively convecting, driving widespread volcanism and tectonic activity. This is the activity that built the giant Tharsis volcanoes and likely caused the cracking that formed Valles Marineris. Today, however, the mantle is much cooler and largely dormant. There is no evidence of active plate tectonics, and large-scale volcanism seems to have ceased long ago. The planet's internal heat engine has wound down, leaving a geologically quiet world. Let that settle like dust on a quiet floor. Fact 47. The outermost layer of Mars is its crust. The Martian crust is made of volcanic rock like basalt. On average, it is much thicker than Earth's crust. Unlike Earth, where the crust is broken into moving tectonic plates, the crust of Mars appears to be a single solid shell. This is called a stagnant lid. This lack of plate tectonics is another key difference between the two worlds. On Earth, plate tectonics constantly recycle the crust and drive geological activity. On Mars, the solid, immobile crust allowed volcanoes to grow to enormous sizes in one place. But it also meant that the planet's internal heat was trapped more effectively, possibly contributing to its faster cooling. Let the body grow heavier as the mind stays simple. Fact 48. The surface of Mars is almost entirely made of volcanic rock, specifically basalt. This is the same type of dark, fine-grained rock that forms from cooled lava on Earth, for example in Hawaii. The vast plains, the towering volcanoes, and the floors of the canyons are all primarily basaltic in nature. This tells us that volcanism was the dominant geological process for much of the planet's history. This basalt has since been weathered by wind and ancient water, and it is covered by the fine iron oxide dust that gives the planet its color. So beneath the red dust, Mars is a dark basaltic world, a planet sculpted from ancient lava flows. Hold the shape of that thought lightly and return to ease. Fact 49. In addition to volcanic rocks, rovers have discovered clear evidence of sedimentary rocks on Mars. These rocks form from the accumulation of sediments like sand, silt, and mud, which are then compacted and cemented together over time. The mudstones found by the Curiosity rover in Gale Crater are a perfect example. These finely layered rocks could only have formed at the bottom of a calm body of water, like a lake. The discovery of sedimentary rocks is profoundly important because they preserve a detailed record of the past environment. They are the pages in which the story of ancient Martian lakes and rivers is written. You can breathe a little deeper and allow the thought to drift. Fact 50. Mars experiences a phenomenon known as frost heaving. In the polar and high latitude regions, the ground contains a lot of water ice. During seasonal temperature changes, the repeated freezing and thawing of this subsurface ice can cause the ground to expand and contract. This process can slowly churn the soil and push rocks into strange patterns on the surface. Over thousands of years, this can create beautiful, geometric patterns of sorted rocks and polygons on the ground. These patterns are a quiet, slow-motion sign of the dynamic interaction between the ground ice and the changing seasons, a subtle form of geology happening right now. Nothing urgent here, only a slow and steady pattern. Fact 51. The InSight lander, which arrived on Mars in 2018, had a mission to study the planet's interior. One of its key instruments was a seismometer, designed to listen for Marsquakes. The instrument was incredibly sensitive, and it successfully detected hundreds of small seismic events. These Marsquakes are much gentler than the earthquakes we experience. They are caused by the slow cooling and contraction of the planet, which creates stress in the crust. Listening to these faint rumbles has allowed scientists to map out the structure of the crust, mantle, and core for the first time. It is like giving the planet a gentle checkup, listening to its faint, ancient heartbeat. Let that idea rest for a moment before we move on. Fact 52. The red dust of Mars is not just on the ground. It is also suspended in the atmosphere, and it is electrically charged. The constant friction from wind blowing the dust particles around, combined with the effects of solar radiation, can build up static electricity. This has led to speculation about whether lightning could occur within Martian dust storms. While no definitive flashes have been seen, some laboratory experiments and theoretical models suggest that small electrical discharges, or sparks, could be possible within the turbulent dust clouds. These would not be the grand lightning bolts of Earth, but faint, quick flashes of light in the heart of a swirling storm. The red planet keeps its steady, silent pace. Fact 53. In the northern polar region of Mars, during the spring, a strange and beautiful phenomenon occurs on the defrosting ice cap. As the seasonal layer of dry ice warms from below, pockets of carbon dioxide gas get trapped beneath the translucent ice. As the pressure builds, the gas suddenly erupts in a geyser-like jet, breaking through the ice. These jets carry dark, sandy material from beneath the ice and spray it out onto the top of the ice sheet. The wind then blows this dark material into beautiful fan-shaped or spider-like patterns. These features, called arenaeoforms, are unique to Mars and are a sign of the active, dynamic processes that occur as the seasons change. Let your breathing find a slower pace. Fact 54. The color of Mars as seen from Earth is not constant. It changes depending on how much dust is in its atmosphere and where we are in our respective orbits. When Mars is having a global dust storm, it can appear brighter and more yellowish from Earth. At other times, when the air is clear, the darker rocky features on its surface become more visible through telescopes, giving the planet a more mottled, reddish-brown appearance. These changes have been observed for centuries by astronomers. They are a reminder that Mars is not just a static point of light, but a dynamic world with its own weather and seasons, its face subtly changing as it journeys through space. Hold only the calm, and let the rest drift. Fact 55. Even though Mars is cold and dry today, there is evidence that it experiences ice ages similar to Earth, but with a different cause. The tilt of Mars's axis is not stable like Earth's. It wobbles significantly over long periods, from as low as 15 degrees to as high as 35 degrees. When the tilt is high, the poles receive more sunlight, and water ice from the polar cap sublimates and moves toward the equator, where it is deposited as snow and ice. This creates glaciers and ice sheets in the mid-latitudes. When the tilt is low, the ice retreats back to the poles. These long, slow cycles of climate change have reshaped the Martian surface many times. Feel the simple ease of being here. Fact 56. The atmosphere of Mars is so thin that the stars would not twinkle. Starlight twinkles on Earth because it is bent and distorted by turbulent layers of air of different densities and temperatures in our thick atmosphere. On Mars, the air is so thin and uniform that the light from distant stars would pass through it almost undisturbed. The stars would appear as sharp, steady points of light against the dark night sky. The Milky Way would be brilliantly clear, a stunning river of light without the soft shimmer we are used to seeing. It would be a stargazer's paradise, a clear and unwavering view into the cosmos. Allow the day to fall away now. Fact 57. Perseverance rover's mission includes a fascinating task for the future. It is collecting and caching small samples of Martian rock and soil. The rover drills into promising rocks and seals the core samples in small, sterile metal tubes. It then places these tubes in selected locations on the surface. The plan is for a future mission, a collaboration between NASA and the European Space Agency, to land on Mars, retrieve these samples, and launch them back to Earth. This would be the first time we could study pristine pieces of another planet in our advanced laboratories here. With simple patience, the rover prepares these small gifts for a future journey home. Settle back into the soft pace of night. Fact 58. The gravity on the surface of Mars is much weaker than on Earth. It is only about 38% of Earth's gravity. This means that a person who weighs 100 pounds on Earth would weigh only 38 pounds on Mars. This lower gravity would make it possible to jump much higher and to lift heavy objects with ease. It is also a key reason why the volcanoes on Mars were able to grow so tall. The rock did not have to support as much weight. This gentle gravity would be one of the most noticeable differences for any future human visitor, a feeling of lightness and effortless movement. There is only stillness in this ancient landscape. Fact 59. Beneath the surface in some regions of Mars, there are features that appear to be lava tubes. These are long, cave-like tunnels that formed in the planet's volcanic past. When a river of molten lava flowed, the outer surface of the flow could cool and solidify, forming a solid roof. The molten lava inside could then drain away, leaving behind a long, hollow tube. These caves could be extremely large, much larger than any on Earth, thanks to the lower gravity. They are of great interest to scientists because they could provide natural shelter from the harsh surface radiation for any future human habitats. They are silent, hidden corridors from a fiery past. Feel the calm gather around you again. Fact 60. The wind on Mars, though it does not have much force, is a powerful agent of erosion over long timescales. The constant, gentle abrasion by wind-blown dust and sand particles has sculpted rocks into fantastic shapes called ventifacts. It has carved out yardangs, which are long, streamlined ridges aligned with the prevailing wind. The wind also moves sand dunes across the planet's surface. Orbiters have watched as entire fields of dark sand dunes slowly migrate over the years, forming beautiful, rippling patterns. The wind is the primary artist on the modern Martian surface, a slow and patient sculptor working with sand and time. Let your shoulders drop and the jaw unclench. Fact 61. The two hemispheres of Mars not only differ in elevation and cratering, but also in the thickness of their crust. The crust under the southern highlands is significantly thicker than the crust beneath the northern lowlands. This adds to the mystery of the Martian dichotomy. One dramatic theory for this difference is that the northern lowlands were created by a single colossal impact early in Mars's history. An object the size of a small planet may have struck Mars a glancing blow, blasting away the crust from the entire northern hemisphere. This Borealis basin, if it exists, would be the largest impact structure in the solar system. Return to the easy rhythm of your breath. Fact 62. While climbing Mount Sharp, the Curiosity rover has found evidence of changing environments over time. The rock layers at the base of the mountain clearly show a long history of lakes and streams. But as the rover has climbed higher into younger rock layers, the evidence has shifted. It has found deposits that suggest a drier environment with intermittent streams and sand dunes. This tells a story of a planet that was slowly drying out. The climate was not stable, but changed dramatically over millions of years, from wet and potentially habitable to the cold, arid desert we see today. Along a steady path, the rover reads this history of gradual loss. Set the idea down and feel the weight release. Fact 63. The moons, Phobos and Deimos, are very dark, some of the darkest objects in the solar system. They reflect very little sunlight. Their surfaces are covered in a layer of fine, dark dust, similar to carbon-rich asteroids. This dark material, combined with their many craters, gives them a dull, ancient appearance. They do not shine brightly in the Martian sky like our own moon. Instead, they would look like dark, fast-moving rocks against the backdrop of stars. Phobos, being larger and much closer, would appear about 1/3 the size of our full moon, while Deimos would look more like a bright star. Rest in the steady comfort of this moment. Fact 64. The surface of Phobos is covered in strange, long, shallow grooves that run for many kilometers. The origin of these grooves has been a puzzle for a long time. Some thought they were fractures caused by the impact that created the moon's largest crater. But a more recent theory suggests they may be stretch marks. The constant tidal pull from Mars is slowly deforming Phobos. It is also possible that the grooves are chains of craters formed by material ejected from impacts on Mars itself that then struck the small moon. Whatever their origin, they give the tiny moon a unique, striated texture. Let that settle like dust on a quiet floor. Fact 65. Recently, scientists using ground-penetrating radar on the Mars Express orbiter found evidence of what may be a large lake of liquid water buried deep beneath the southern polar ice cap. The radar signal suggested a body of water about 20 kilometers across, located about 1.5 kilometers below the ice. The intense pressure from the ice above, combined with a high concentration of dissolved salts, could keep the water in a liquid state despite the extreme cold. If confirmed, this would be the first discovery of a stable body of liquid water on modern Mars, a hidden lake in the deep, freezing darkness. Let the body grow heavier as the mind stays simple. Fact 66. The names of features on Mars are chosen by the International Astronomical Union. Craters are named after famous scientists and science fiction authors. For example, there are craters named after Leonardo da Vinci, Isaac Asimov, and Ray Bradbury. Larger craters are named after towns and villages on Earth. The best canyons and channels often have the word for Mars in different languages. For example, Ma'adim Vallis uses the Hebrew word for Mars. This system of naming connects our exploration of this new world with the history, culture, and imagination of our own. As we rest, these names form a quiet map of human curiosity. Hold the shape of that thought lightly and return to ease. Fact 67. Mars lacks an ozone layer. On Earth, the ozone layer in our upper atmosphere absorbs most of the sun's harmful ultraviolet radiation. Without this protection, the surface of Mars is bathed in high levels of UV radiation. This radiation is strong enough to break down complex organic molecules and would be lethal to most life as we know it. This is another major challenge for the possibility of life on the Martian surface today. Any potential life would likely need to be underground or have some other means of shielding itself from the intense and constant bombardment of ultraviolet light from the sun. You can breathe a little deeper and allow the thought to drift. Fact 68. The poles of Mars are not centered on its rotational axis. The geographic poles are where the planet's axis of rotation meets the surface. The ice caps, however, are offset from these points by a few degrees. This is because of the local climate and geography. In the north, the massive ice cap sits in the low-lying basin of the northern plains. The position and size of the caps are influenced by the atmospheric circulation and long-term weather patterns. This slight off-center placement is another of the planet's gentle asymmetries, a small quirk in its otherwise orderly seasonal cycles. Nothing urgent here, only a slow and steady pattern. Fact 69. The northern polar cap of Mars has a remarkable spiral pattern of troughs and canyons carved into its ice. These spiral valleys wind outward from the center of the cap. Scientists believe they were formed by a combination of factors. The ice sublimates faster on the sun-facing slopes, and the planet's strong Coriolis effect, caused by its rotation, directs the winds in a spiral pattern. Over thousands of years, these winds have slowly etched the spiral troughs into the ice. It is a stunning example of how gentle, persistent forces can create large-scale, beautiful patterns in a landscape, a pinwheel of ice sculpted by wind. Let that idea rest for a moment before we move on. Fact 70. In 2018, the European Space Agency's Mars Express orbiter took a stunning picture of a crater near the North Pole named Korolev Crater. This crater is about 82 kilometers across, and it is filled to the brim with water ice all year round. The crater floor is very deep, about 2 kilometers below the rim. This creates a natural cold trap. Air moving over the ice cools down and sinks, forming a permanent layer of cold air that shields the ice from melting or sublimating away. The result is a vast, pristine sheet of ice, like a giant frozen lake, sitting peacefully inside the crater walls. The red planet keeps its steady, silent pace. Fact 71. The rocks on Mars have a different texture than many rocks on Earth because of the constant, gentle wind erosion. Without rain to wash away fine particles, the wind slowly sandblasts the rocks, creating a pitted and fluted surface. The wind can also carry very fine magnetic dust that sticks to the rocks, giving them a thin, dark coating. Rovers have a special tool called the rock abrasion tool, which is like a small grinder. They use it to grind away the outer weathered surface of a rock to expose the fresh, pristine material inside for analysis. This allows scientists to see past the effects of the Martian weather and read the rock's true history. Let your breathing find a slower pace. Fact 72. The soil on Mars, more accurately called regolith, contains compounds called perchlorates. These are a type of salt that were first detected by the Phoenix lander near the North Pole and have since been found elsewhere. Perchlorates are interesting because they can act as a powerful antifreeze, lowering the freezing point of water. This could allow salty brines to remain liquid at the very low Martian temperatures. However, they are also toxic to many forms of life as we know it, and can degrade organic molecules when heated, which complicates the search for biosignatures. With a steady breath, we see the complex chemistry of this alien soil. Hold only the calm and let the rest drift. Fact 73. The Phoenix lander, which arrived in 2008, was sent to the far northern plains of Mars to study the water ice just beneath the surface. It had a robotic arm that scraped away the top layer of soil and exposed the bright white water ice below. One of the mission's most famous images shows a trench with small clumps of this ice. Over a few days, the lander watched as these small clumps slowly disappeared. They were sublimating, turning directly from solid ice into water vapor in the thin air. It was the first time we directly witnessed the water cycle in action on another planet. A slow, quiet, vanishing act. Feel the simple ease of being here. Fact 74. The Perseverance rover carries a small instrument called MOXIE. Its purpose is to test a technology that could be vital for future human exploration. MOXIE is designed to produce oxygen from the carbon dioxide in the Martian atmosphere. It works by sucking in the Martian air and using an electrochemical process to split the carbon dioxide molecules into oxygen and carbon monoxide. It has successfully generated small amounts of pure oxygen. On a larger scale, such a device could produce breathable air for astronauts and, even more importantly, the oxygen needed as a rocket propellant for the journey back to Earth. Allow the day to fall away now. Fact 75. The journey from Earth to Mars is a long one. Because both planets are constantly moving in their orbits, spacecraft cannot fly in a straight line. Instead, they follow a long curving path called a Hohmann transfer orbit. This is the most fuel-efficient way to travel between two planets. The spacecraft is launched from Earth and put into a larger orbit around the Sun that intersects with Mars's orbit at the other end. The trip takes about 7 to 9 months. It is a long, quiet coast through the emptiness of space, waiting for the gentle pull of Martian gravity to draw the spacecraft in. Settle back into the soft pace of night. Fact 76. Clouds do form on Mars, but they are different from the clouds on Earth. They are very thin and wispy, made of tiny crystals of either water ice or carbon dioxide ice. Water ice clouds often form around the peaks of the large volcanoes, where the air is forced to rise and cool. These are called orographic clouds. Carbon dioxide clouds form in the polar regions during the winter when temperatures get extremely low. These thin, feathery clouds drift through the pale Martian sky, a subtle and beautiful feature that reminds us that even this thin atmosphere has its own quiet weather. There is only stillness in this ancient landscape. Fact 77. Occasionally, a very long, thin cloud appears over the volcano, Arsha Mons. This cloud can stretch for up to 1,800 kilometers, making it a dramatic feature in the Martian sky. It is not a plume from an eruption, as the volcano has been dormant for millions of years. Instead, it is a water ice cloud that forms when moist air is pushed up the slopes of the volcano. The cloud appears regularly every Martian year around the time of the southern winter solstice and can persist for several hours each morning. It is a predictable and beautiful weather event, a long white banner streaming from the silent mountain. Feel the calm gather around you again. Fact 78. Mars has no oceans, but it does have vast plains covered in dark sand dunes. One of the most stunning is a large sea of dunes that encircles the northern polar cap. These dunes are made of dark basaltic sand, and they create a stark contrast against the bright white of the ice cap. In the spring, as the seasonal dry ice layer disappears, patches of the dark sand are revealed, creating beautiful patterns. The wind constantly reshapes these dunes, causing them to slowly migrate across the plains. They are like a dark, frozen ocean, its waves moving in slow motion over centuries. Let your shoulders drop and the jaw unclench. Fact 79. In the 1990s, a meteorite was found in Antarctica that was identified as having come from Mars. It was named Allen Hills 84001. This rock was blasted off the Martian surface by an impact millions of years ago, and it wandered through space before landing on Earth. When scientists studied it, they found tiny structures inside that some thought could be fossilized microbes. The evidence is highly controversial, and most scientists are not convinced. Still, this small rock provides a tangible link between our two worlds and fueled a renewed interest in the search for life on Mars. Return to the easy rhythm of your breath. Fact 80. Landing on Mars is famously difficult. The atmosphere is thick enough to cause significant heating of a descending spacecraft, but it is too thin to slow it down enough with parachutes alone. This has led to a multi-stage landing process that some engineers call the 7 minutes of terror. A spacecraft enters the atmosphere at high speed, protected by a heat shield. Then a large parachute deploys. Finally, In the last moments, rockets must fire to slow the craft down for a soft landing. For the Curiosity and Perseverance rovers, this involved a complex sky crane maneuver, where the rover was lowered to the surface on cables. Set the idea down and feel the weight release. Fact 81. The wind on Mars creates mesmerizing ripples and patterns in the sand. Besides the large dunes, there are smaller wave-like features called transverse aeolian ridges, or TARs. These are mysterious, medium-sized ripples that are common across the planet. But their exact formation is not well understood. They seem to be made of coarser sand grains than the dunes around them. They lie in the middle ground between small, simple ripples and the giant, migrating sand dunes. They are another example of the complex and beautiful textures that the Martian wind creates as it patiently works on the surface, leaving its subtle art everywhere. Rest in the steady comfort of this moment. Fact 82. Ancient Mars may have had a much denser atmosphere, possibly as thick as Earth's is today. This early, thick atmosphere would have been necessary to keep the planet warm enough for liquid water to be stable on the surface. So, what happened to it? The leading theory is that the loss of Mars's global magnetic field left the atmosphere vulnerable. The solar wind, a stream of charged particles from the sun, was able to slowly strip gases away from the top of the atmosphere, particle by particle. This process, happening over billions of years, thinned the air to the faint whisper it is today. A world away, a planet slowly lost its breath. Let that settle like dust on a quiet floor. Fact 83. The MAVEN orbiter, which stands for Mars Atmosphere and Volatile Evolution, arrived at Mars in 2014. Its specific mission is to study the Martian upper atmosphere and its interaction with the sun and solar wind. MAVEN has been measuring the rate at which Mars is currently losing its atmosphere to space. By understanding this process today, scientists can extrapolate backward in time to understand how Mars transformed from a potentially habitable planet into the cold desert it is now. The mission is piecing together the story of this great planetary change, one disappearing atom at a time. Let the body grow heavier as the mind stays simple. Fact 84. Many of the canyons and valleys on Mars show evidence of massive outflow, floods in the distant past. These were not gentle rivers, but catastrophic deluges. Scientists believe they were likely caused by the sudden release of huge amounts of groundwater that had been trapped beneath a layer of frozen ground. A volcanic event or a large impact could have heated the ground and melted the ice, releasing a torrent of water that scoured the landscape in a very short time. These floods carved the huge outflow channels we see today, many of which are far larger than any river channel on Earth. They are scars from a brief, violent, watery past. Hold the shape of that thought lightly and return to ease. Fact 85. Because Mars is farther from the sun, the sunlight that reaches its surface is weaker than on Earth. On a clear day, the brightness at noon on Mars would look similar to a heavily overcast day on Earth. This dimmer light, combined with the butterscotch-colored sky, would give the entire landscape a muted, gentle illumination. Shadows would be soft, and the colors would be less vibrant than in direct Earth sunlight. It would be a world of soft focus, where the light itself seems old and tired, bathing the ancient red rocks in a permanent, quiet twilight. You can breathe a little deeper and allow the thought to drift. Fact 86. The surface of Mars is littered with craters of all sizes. These are the scars from impacts by asteroids and comets over billions of years. Because Mars has so little geological activity and erosion, craters are preserved for a very long time. The number and size of craters in a given area can be used to estimate the age of that surface. A heavily cratered surface, like the southern highlands, is very old. A smooth surface with few craters, like the northern lowlands or the slopes of Olympus Mons, is much younger. In this way, the craters serve as a cosmic clock, allowing us to read the planet's deep history. Nothing urgent here, only a slow and steady pattern. Fact 87. Some of the sand dunes on Mars have a very special feature in the winter. They get covered by a seasonal layer of carbon dioxide frost. This gives the dark dunes a beautiful speckled appearance. As spring arrives and the sun warms the frost, it sublimates away, but it does so unevenly. This process can create strange dark patches and streaks on the dunes as the underlying dark sand is revealed. The effect is a dynamic, shifting pattern of black and white that changes from day to day as the frost disappears. It is another of Mars' quiet, seasonal beauties, a monochrome painting that lasts for just a few weeks. Let that idea rest for a moment before we move on. Fact 88. The poles on Mars are not just ice. They are made of layered deposits of ice and dust that have built up over millions of years. These layers are called the polar layered deposits. Like tree rings or ice cores on Earth, these layers hold a detailed record of the planet's past climate. Each layer corresponds to a different period in Mars's history, with variations in the amount of dust and ice, telling a story of changing seasons and long-term climate cycles. Scientists hope to one day drill into these deposits to read this history, which may go back hundreds of millions of years, locked in the deep, cold ice. The red planet keeps its steady, silent pace. Fact 89. The name of the first rover, Sojourner, was chosen in a student competition. It was named after Sojourner Truth, a 19th century African-American abolitionist and women's rights activist. The name was chosen because it means traveler, and the mission was seen as a journey to uncover truths about Mars. The lander was named the Carl Sagan Memorial Station, in honor of the famous astronomer and science communicator who inspired so many. And the two small moons, Phobos and Deimos, come from ancient Greek mythology. Without any hurry, we connect our journeys to our stories, reaching for the stars with our history in tow. Let your breathing find a slower pace. Fact 90. The Curiosity rover has an instrument that can detect methane in the Martian atmosphere. Methane is an interesting gas because on Earth, most of it is produced by living organisms. The rover has detected very low levels of methane, but strangely, the amount seems to rise and fall with the seasons, and sometimes there are unexplained sudden spikes. The source of this methane is a complete mystery. It could be produced by geological processes, like the interaction of water and rock, or it could potentially be a sign of surviving microbial life deep underground. For now, it is one of the most tantalizing clues in the search for life on Mars. Hold only the calm and let the rest drift. Fact 91. Even with our most powerful telescopes on Earth, Mars is a difficult planet to observe in detail. This is because its apparent size in our sky changes dramatically as our two planets move in their orbits. For a short time every 2 years or so, Earth and Mars are relatively close together in an event called opposition. This is the best time to view the planet. But for much of their orbits, they are very far apart, and Mars appears as just a small, fuzzy, reddish dot. This is why our understanding of the planet was so limited until we could send spacecraft there. With simple patience, we have learned to see this world up close. Feel the simple ease of being here. Fact 92. The wind on Mars can create a faint humming sound. The Perseverance rover has microphones that have captured the ambient sounds of the planet. And in the recordings, there is a very low, almost inaudible hum. Scientists believe this might be the sound of the wind interacting with the rover itself, causing parts of it to vibrate. It's also possible it's an acoustic effect of the Martian atmosphere itself. Whatever its origin, it is the background noise of the planet, a subtle, low-frequency drone that is always present. In the great silence of Mars, there is a soft and steady hum. Allow the day to fall away now. Fact 93. In the southern polar region, the permanent ice cap is not made of water ice alone. It is a mix of water ice and frozen carbon dioxide that is stable year-round. But in some places, the carbon dioxide ice has formed strange, flat-bottomed pits that give the surface the appearance of Swiss cheese. These pits form as the dry ice sublimates away during the summer, leaving behind the underlying water ice. The pits grow larger and merge over many years. This Swiss cheese terrain is another unique and beautiful feature found only on Mars, a slow erosional process happening in the planet's coldest regions. Settle back into the soft pace of night. Fact 94. The future of Mars exploration will likely involve more than just rovers. There are concepts for sending balloons or gliders that could ride the Martian winds and cover vast distances. These could survey the landscape from a higher altitude than a rover, but with more detail than an orbiter. The success of the Ingenuity helicopter has proven that powered flight is possible, opening the door for more advanced aerial explorers. These future missions could explore hard-to-reach places like the steep walls of Valles Marineris or the rugged terrain of the southern highlands, giving us a new, bird's-eye view of the red planet. There is only stillness in this ancient landscape. Fact 95. Our journey to Mars has been a long one, not just for the spacecraft, but for humanity. For centuries, we looked up at that reddish point of light in the sky and wondered what it was. We imagined canals and civilizations, deserts and oceans. Now, through the patient work of science and exploration, we see it for what it is. A world that is ancient, silent, and starkly beautiful. It is a world that may have once been like our own, and which still holds many secrets in its red dust and frozen ice. The story of Mars is still being written, and each new discovery is a quiet verse in a poem that spans billions of years. Feel the calm gather around you again. Outro. And so, our gentle exploration of Mars comes to a close for tonight. We have wandered across its quiet plains, stood at the base of its giant sleeping volcanoes, and peered into the depths of its immense canyons. We have felt the thinness of its air and watched its surprising blue sunsets. Mars is a world of memory, a place that holds the faint echoes of ancient rivers and lost oceans. As you settle deeper into your rest, you can let these images drift. The red dust, the frozen poles, the two small moons in their slow dance. There is nothing more to hold on to. The night is here, and you are safe and sound. Sleep well now, and dream deeply.